Hi, my name is Bill Dally. I'm Chief Scientist and Senior Vice President of Research at NVIDIA Corporation. I'm also a professor at Stanford University.
Professor Dally, what are, according to you, the major upcoming challenges in computing?
Well, as indicated in my keynote this morning, there are two really fundamental challenges we're facing in the next few years in all sorts of computing, from supercomputers to cell phones. The first is that of energy efficiency. With the end of Dennard scaling, we're no longer getting a big improvement in performance per watt from each technology generation. That performance improvement has dropped from a factor of 2.8x, back when we used to scale supply voltage with each new generation, now to about 1.3x in the post-Dennard era. And with this comes a real challenge for us to come up with architecture techniques and circuit techniques for better performance per watt. And two big examples of that are reducing overhead, which in today's scalar processors tends to account for more than 99% of the energy, is not payload arithmetic operations, but rather is organizing and scheduling the work. In our GPUs, we tend to improve that to where almost 50% of the energy is going into useful operations. The other big opportunity for energy efficiency is with communication. By using more efficient signaling circuits, we can improve signaling efficiency from 200 femtojoule per bit millimeter to about 20 femtojoule per bit millimeter. And taken together, those can give very great improvements in performance per watt. The other big opportunity and challenge is that of parallelism. Processors aren't getting faster anymore, they're getting wider, and that is, we're getting more parallel cores working together to solve a problem rather than one serial core solving it faster. And the real challenge of parallelism is one of programming. And if we take the right abstractions, we can make parallel programming easy, whereas too often today, by doing manual synchronization and manual mapping, people are making parallel programming very hard. And so we're looking at trying to develop target-independent programming systems and very powerful tools to help people do their mapping, so that people can get very good performance from parallel programs, but still make it very easy to program.
Thank you very much for sharing your insights to the HiPEAC community.
Well, thank you.